Radio broadcasting, modulation and demodulation. The developments in the field of communication have revolutionized our lives. We live in an era where the quest is on for faster and faster modes of communication. Let us first understand the basic components of a communication system. Any communication system which propagates and intercepts electromagnetic waves has a transmitter, a communication channel, and a receiver. Click on the highlighted components. Communication channel, also called a circuit or line, is a pathway over which data are transferred between remote devices. It may refer to the entire physical medium such as a telephone line, optical fiber, coaxial cable or twisted wire pair, or it may be air in the case of wireless. Transmitter is a set of equipment used to generate and broadcast electromagnetic waves carrying messages and signals, especially radio or television signals. A receiver is a device such as a part of a radio, television set or telephone that receives incoming waves and converts them to perceptible forms such as sound or light. Modulation of waves in radio broadcasting. A radio station generally broadcasts speech or music. These audio signals are weak and die away with distance. The audio signals are converted into electrical signals by a microphone and then amplified. These amplified signals are then superimposed on a wave that has been generated by an oscillator circuit in the transmitter. The radio waves which carry the audio signals are generally referred to as carrier waves. This process by which audio signals to be broadcasted is superimposed on radio waves is called modulation. The modulated wave is amplified and then radiated out into the space from the antenna in the form of electromagnetic waves. Types of modulation. In modulation, the carrier wave is processed in such a way that its amplitude, frequency, or some other property varies. Thus, modulation can be classified as amplitude modulation, frequency modulation, pulse modulation, phase modulation. Amplitude modulation. In amplitude modulation, the carrier signal is modulated so that its amplitude varies with the changing amplitude of the modulating signal. The frequency and phase of the carrier wave remain the same. The modulating signal becomes an envelope to the carrier. The main drawbacks of AM are noisy reception, low efficiency, and lack of audio quality. Frequency modulation. In frequency modulation, the frequency of the carrier signal is changed to accommodate the change in voltage or amplitude of the modulating signal. TV transmission uses FM for sound waves and AM for picture signal. Pulse modulation. Pulse modulation is used if the modulating signal is in the form of short bursts or pulses. In this type of modulation, the carrier wave will also be in the form of short pulses. Pulse modulation is used to transmit digital data. This type of modulation can be used to transmit information over long distances with hardly any interference or distortion. Phase modulation. In this type of modulation, the phase of the carrier wave is varied. The phase modulated wave is obtained by summing up two radio frequency waves shifted in phase by 90 degrees, one of which is amplitude modulated. The phase of the resultant wave varies according to the amplitude of the AM wave. Demodulation of waves in radio broadcasting. The process of recovering the audio signal from the modulated wave is known as demodulation or detection. After traveling long distance, the modulated carrier wave is picked up by the antenna or aerial of the receiver. Receiving antennas change it back to the form of electrical signals and feed it to a receiver. Here, the audio frequency signals are separated from the carrier wave. This process by which the radio frequency wave and audio frequency wave are separated is known as demodulation.